So what is a limit? A limit is the value, the y-coordinates of points on a function approach when approaching a certain x value. Here's a sample. I've got the function f of x equals x squared, and we're asked what is the limit as x approaches 2 for this function. With the notation, it would look like this. Underneath the limit, we indicate what x value we are interested in approaching. This is the graph of f of x equals x squared. When I'm looking to evaluate the limit as x approaches 2, I'm looking to find the y value that the points of the function are approaching as they move closer and closer to x being equal to 2. So you can see I can move this point and it stays on the function. So I'm watching the y-coordinates. Here I'm at 0. My decimals continue to climb till I get to 1. And again, I'm interested in the y-coordinate here. I'm letting the x-coordinate get closer and closer to 2. And the y-coordinate, notice, approaches 4. Now we have to pay attention to the trend in the y values on the left side of the x value we're interested in and on the right. So I've taken my point to the right now. And as I drag it closer to x equals 2, again, I watch the y-coordinates, and I can see that they approach 4. So it would be correct to say that the limit of this function f of x as x approaches 2 equals 4. And because the y values trend towards 4, we would say the limit as x approaches 2 of the function x squared equals 4. In order for a limit to exist, the limit when approaching from the left side of x must be the same as the limit when approaching from the right side. So for instance, we can be asked just for a left side limit. What's the limit as x approaches 0 from the left side for f of x equals 2x minus 1? With the notation, you'll notice we're approaching 0 and there'll be a little minus sign to the right of it. That's indicating that we are approaching from the left. A negative sign there always means approaching from the left. As I approach from the left-hand side of this point, again, I'm watching the y-coordinates as x becomes closer and closer to 0. And I notice the y-coordinates are approaching -1. So the answer would look like this. Now, if we approach from the right side, our notation will change. You'll see a little plus sign after the 0. And again, these signs are put after the number to avoid confusion with just being a negative number or a positive number. I repeat this from the right side, letting x get closer and closer to 0 and watching my y-coordinates. The y-coordinates are approaching -1. And once again, the limit is equal to -1 on the right. So because of that, when I'm just asked what the limit is as x approaches 0 for this function, here I would lose the left and right hand side notation because I just want the overall limit, and the overall limit would be -1 since that's what both side limits were equal to. Here I've defined a piecewise function. And I'm being asked what's the limit as x approaches 0 for this f of x. In notation, because it's a piecewise function, rather than stating it explicitly, we usually just use the name of the function f of x. As I approach 0 from the left and watch my y-coordinates, they're getting very close to -2. Now, even though I have an open circle at -2 and the function does not have a value there, I'm still approaching -2 as I approach 0 from the left side. So we would say the left-hand limit is equal to -2. Now as I approach 0 from the right, you can watch the y-coordinates getting closer and closer to 0. So the right-hand limit would be 0. If the left-hand limit and the right-hand limit don't agree, as in this case where we have the left equaling -2 and the right equaling 0, there is no overall trend in the y values, and therefore there would be no limit, or we would say DNE, does not exist. Okay, so here's how you get Mathematica to help you evaluate limits. We're going to talk about creating tables of values to explore limits and using the limit command to find limits, left-hand limits, and right-hand limits. In our first example, we're asked to create a table of values to investigate this limit. Use the following x values. All right, you saw in the last lab how to create a table of values. To begin with, I'm going to store my function. Next, I use the table form command to make sure my table will look like a table, then the table command. And since I have a list of x values, this is the proper syntax. I'm going to do table 1 first. And then I'm going to put some headings on my table, remembering to include the empty set of set brackets. And you can see here is my table of values. Now, we saw how to find limits on a graph. When you're looking at a table, you just move in the direction closest to the x value you're trying to evaluate. So we're trying to approach 3. So 3.1 is the biggest number on this list. And then I look closer and closer and closer to 3. As the x coordinates are doing that, the y coordinates seem to be getting closer to 5. So it appears that this limit is going to equal 5. However, I've only checked one side. In this case, I've checked the right-hand side because these are the numbers that are bigger than 3. I'll now edit my command to view the left-hand side. And once again, I look at the x values as they get closer and closer to 3, and I can see that the y values, again, do appear to be trending towards 5. And since the left and the right sides agree at 5, it looks like the overall limit will equal 5. But we do have some built-in commands in Mathematica to verify this. So our next sample asks us to use the limit command to verify our answer. And we'll check the left and the right-hand limits. Okay. The command for finding a limit is pretty straightforward. You just say limit, square bracket, put in the name of your function, and then put x with an arrow. Again, you would use the subtraction sign and the greater than sign, and then you put the number you want to approach. And it confirms that my limit is 5. If I want to do a limit just from the left or just from the right, I would modify this command. I would use the same first two arguments, however, I would put direction with an arrow. And notice you've got choices here, from above, from below. If I want to do from below, it tells me it's 5. So that would be the left-hand limit. Or I can choose from above, which would be my right-hand limit. There's one other way to do this. It's a little bit less straightforward, but just for the sake of showing you everything, you can also refer to the directions left and right using a number. So if you want to approach from the left, you have direction, arrow, +1. That'll be your left-hand side. And go back. And if you want to say do the right-hand limit, you would put a negative on it. Here's a summary of the left and right-hand commands.